Hello viewers, I remain Beatrice Christopher from Statistics Scribe. God's willing, in these tutorials I'm going to explain to you how to perform bivariate correlation analysis using R. Okay, so I am using R Studio as an IDE. Remember, as a sample we have such data here, X and Y variables here. So quickly on to perform that, you can click enter on the R script. Okay, so on line 3 here in my line of code, I can call it COR. The correlation coefficient function is the correlation function. Okay, so I'm going to then open parenthesis. I'm going to type, I want to correlate X and Y, then X comma Y. That's all. So but you should take note of the fact that this function here only applies to Pearson's correlation coefficient, okay, like in the case of parametric test. Okay, so I want to run it, I'll select all, command enter for Mac users and control enter for PC users. So as you can see, this is my output. It's showing me that my correlation coefficient is 0.906789. This is the Pearson's correlation coefficient by default. Okay, so the assumption here is that this data follows normal distribution and other parametric assumptions. So let's say you want to run other non-parametric correlation coefficients like the Kendall rank correlation coefficient or the Spearman's rank correlation coefficient. So let me show you something else. Go to line 4. In this case, I want to perform correlation, then correlation of X comma Y comma, then the next thing you have is method. You have to state the method you want to use. Method equals, now the method I want to use is Pearson. I just want you to see that you can actually perform the Pearson's correlations coefficient. That's for the parametric, which will be the same as we've gotten previously. Pearson. So this is the method of correlation I want to run. So quickly I can select the lines of codes, observe again, all, command enter, observe. Check the values here. The value for the correlation of X and Y here is the same thing here, 0.906789, and the same for this, 0.906789, because the method here is Pearson, and by default the method of correlation here is Pearson. So let's assume I don't want it to be Pearson. I want to use the Kendall's rank correlation coefficient, otherwise known as Kendall's tau coefficient. Okay, sometimes Kendall's tau b, so now, which is beta. Now let's see quickly. I want to perform that. Observe how it's going to differ amongst all the threes. So I'm erasing all of this, or let me just change the method anyway. Method to Kendall. Okay, then I'm going to rerun the analysis. I'm rerunning it. My bad. Have a spelling error. I'll have to go back here and correct it. Kendall, so you can see here. So it has affected the correction I have. Okay, so quickly observe the correlation coefficient here is 0.8095238, which is different from 0.906789. so this one here is for the Kendall. Okay, so quickly I want to change the method here to Spearman. So meaning, let's assume you want to perform Spearman's rank correlation coefficient, which is called the rho. Okay, so quickly select all. So observed here, you run it, see this is what I'm having, 0.9285714. so you see all the three methods gives us three different answers. Okay,